Okay, acceleration is a rate at which velocity changes. Okay, and is measured in meters per second squared. This is really, really, really important. You need to know that acceleration is meters per second squared. If you want to draw a particle model, you can see in this one they've got people, and then in this one they've got dots. Okay, so you can see the larger distance between each dot means that it's speeding up and it's covering more distance in that amount of time. So if each of these were 1 second, you can see he's covering more distance in each time period. And if it's slowing down, the dots are going together. So on your test, you may have to draw a particle model where something is speeding up, and you would just kind of draw something like this. And then if you wanted to draw something where something was slowing down, you would just kind of do this. So, and it's, if I don't give you numbers, it doesn't have to be really specific, but you do need to know speeding up, the dots are farther apart, and slowing down, the dots are closer together. So to calculate average acceleration, we'll take the change in velocity divided by the time interval. So our formula will actually end up being like this. Okay, and you can see if you look at this graph, this is a velocity time graph, which I'll talk to you about in a little bit. But we have velocity on the y-axis, and you can see here we have velocity on the y-axis, and you have time on the x-axis, which is what you have here. And so your slope for this graph is actually going to be acceleration. Okay, and instantaneous acceleration, this involves calculus. It's basically like the second derivative. And so we're not going to really do this because we don't do calculus unless you calculate at like this point or something like that. We will do average acceleration. So if you want to calculate acceleration, this is that formula I just showed you. You have your final velocity minus your initial divided by your final time minus your initial time. A lot of times your initial time and your initial velocity will be 0, and so that'll make it a little easier to do. This is another velocity and acceleration formula. We have quite a few just to make sure. And again, this equation is basically just kind of reworking the other ones, the one we just had. And so you can see if you take the minus initial velocity minus initial, you have VF minus VI equals A delta T. Divide both sides by delta T. And that's basically TF minus TI. So you have, it's the exact same formula. They've just kind of drawn it without the fraction part. Okay, this is another acceleration formula. You'll have these on your formula sheet. You won't have to memorize them, but you will have to know when to use each one. And it basically just depends on what they give you. Depending on whatever the problem gives you, will help you decide which formula you'll need to use. And then here's another one. And again, it just depends on what they give you. So it allows you to calculate acceleration even if you don't have time and velocity. Like this one doesn't have time, but it allows you to still calculate acceleration as long as they give you the distances. So these are our formulas. And this is just kind of like a little chart. Sometimes it's helpful to some people. It's not super helpful to me.